All right. Here we go. So solving equations using quadratics using square roots. Okay. So we've been doing this. But unfortunately, we showed something. So let's say up until this point, if we had this kind of problem, I was asking you to write zeros appropriately. I was asking you to do this. Do you agree with that?
Yes.
Okay. So I was purposely doing that way because it's important to. It was important for me on the factoring, so you had a consistent, always the same way of doing stuff. Okay. Yes. So this was the way that we had done it, and if you kind of realize we multiply those together, you get -4. You realize you have plus minus. You know, 2 and the 2. You plug those back in order to get that, right? So that was the start of factoring, and there was a rhyme to my madness and reasoning. So I think you don't have that one, but you have this one. So far we've definitely done these equations. When I did this equation, again, I had you put in the middle of it a 0x. Okay? So now, I'm not going to unlearn you a concept, but let's go back 7 weeks ago prior to me teaching any of this. So 7, 8 weeks ago prior to me teaching this, something that you might have thought about doing here is going, okay, I'll add 20 to both sides, and then you wind up getting x squared equals 20, and then you're like, I'm stuck. Okay? So basically what that means is there some number times the exact same number that would give me 20? Well, with this understanding, not yet. We will get there though. Okay? So that's definitely a thing. So a lot of times you get to this point, especially 7 weeks ago, after today, we're actually going to realize what happens. Okay? So I believe you have, in the drawer underneath the tin can. Okay. So can you bring my computer back too? So my computer is underneath that. Yeah, we're going to challenge her. Just pick it up there. Come over. See where the aluminum can is? Yeah. Open the drawer. Are they there?
Yeah. There's a baseball too.
Cool. Leave the baseball.
Yeah, baseball.
Bring it back here. Bring it back here, and don't drop my computer. Please. You taught at Oberlin? No, I have all of the schools on there because I used to go to all the schools. All right, so prior to doing any of this stuff, when I had done this particular problem, I basically would have said, we would have gone through these steps in the old school way. But now I'm going to start following this. So let's get x alone. So I think you're okay with this. X squared equals 4. So that satisfies this first step. Now, friends, 2 thoughts that take place on this problem. Can you think of a number that I could multiply by itself and get 4? What would that be? 2. 2 times 2 is 4. Agree? Okay. But you remember when I said when you're raised to the second power, you have 2 solutions? Well, you only gave me 1 solution telling me that 2 times 2 is 4. But this squared means we have 2 solutions. Oh, and friends, if you would make sure at some point, not all at once, get up there and get your phones up there, please. All right. So let's focus on the second step. It says find the square root of both sides. Find the square root of both sides. So root. Okay? So let me ask you this. What is this answer? That's just x, right? Okay? Now, when I take the square root of both sides, you have to have a plus minus that becomes part of the answer. Okay? So you told me that 2 times 2 is 4. So positive 2 times positive 2 is indeed equal to positive 4. Agree?
Yes.
But you also know that negative 2 times negative 2, negative times negative is positive, 2 times 2 is 4, is also positive 4. So this right here, that is both answers. We have a positive 2 for an answer and a negative 2. Have we satisfied the two solutions with this?
Yeah.
Yeah. Okay, so this type of problem right here would probably be worth 3 points. If you forgot to put the plus minus, you're going to miss one of the 3 points. Okay, so remember there's 2 answers. So when you take the square root of both sides,
What's the line under the equal?
what?
What's the line under the equal? Oh, sorry. Line under the addition sign.
Plus minus.
Oh.
Okay, so when you take the square root of both sides, you need one side to have plus minus. So the big key from this is when you take the square root of both sides, you're going to have a positive and a negative component. Okay? Is that all right? So let's take this and turn it into something more. You ready? I can wait. Bum, 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 bum. Good? Everyone else good? Good in the hood? Wilbur, good? Yeehaw. All right. So, big thing here. When you're doing a plus or minus sign, there will be 2 answers. There is going to be a plus and a minus. Okay, you put them together. That means you have a positive component and a negative component. Don't forget this. The only time this happens is if you happen, if I said, what's the square root of 9? The square root of 9 is 3. But if I said x squared equals 9, root, if I take the square root of both sides, a plus minus has to happen. All right, so let's take a look at this next problem. Would you feel comfortable with me doing this to each side of the equal sign as a first move?
Yeah.
Make sense? So that's going to give me 2x squared equals 32. Is there any thoughts if I did goofy? We're good? All right, so I want the x squared to be left alone. I want it to be by itself. What should I do to get x squared all by itself? Divide by 2. There you go. Divide each side by 2. So those are going to cancel. So then I get x squared is equal to 16 because 32 over 2 is 16. Agree? All right, friends. Root. Don't forget the? Yeah, so the plus minus. Okay, so I'm just putting that plus minus. We'll insert it in a sec. The square root of x squared is x. What's the square root of 16? 4. So my answer to this problem is plus or minus 4. This is 2 answers. This means one answer is positive 4, one answer is negative 4. We shortcut it to go plus minus 4. That means both. Okay? And again, I had originally shown you when we were factoring these to solve them, to plug a 0x in. That way you had the exact same process as you were working through it to solve it. Now I'm undoing that a little bit to shorten it. You certainly could still do this problem like this, where you multiply those together, you get negative 64. You realize you have a positive and negative component. You want to figure out the factors that give you that. So you have positive 8 and negative 8. Okay, plug them in, factor it, and it would solve to the exact same answer. But this was a longer way, and it was okay that I was showing you the longer way because I wanted you to become more and more comfortable with factoring 3 parts. Okay, but now when we're missing the x part, we don't have a number x, or we don't have to add a 0x. We can solve it just by doing that method. May I move up to the next screen? Good? Good? Good over there? All right. So those were when we had a perfect square. So let's look at this one. Would you feel comfortable with this as my first move?
Yes, sir.
So those cancel. So I get 3x squared equals 24. Okay, what's the next step here?
Divide the 3.
Divide each side by 3. Very good. Those cancel. So I get x squared equals 24 over 3, which is 8. Now I'm going to go root. Don't forget the plus minus. So the answer will have plus minus. So right now the answer that we can see here would be this. This problem is a 4-point problem. Right now you're getting 3 of the 4 points. Why do I say you're only getting 3 of the 4 points here?
Because there's no root.
Okay, root 8. Root 8 is like here. So can I break root 8 up into a perfect square times something else? Yeah, what does it break up to? 4 and 2, or 2 and 4. What's the square root of 4? So I get 2 root 2. So plus or minus 2 root 2. Notice there's a plus minus. Okay? Plus minus is part of the answer. If you forget to do the plus minus, now, my friends, this doesn't mean that all answers from here on out for the rest of the year has plus minus as part of it. Okay? Just realize if you take the square root of each side of an equation to solve it, one of the sides, and it's normally the side that has the number on it, will have the plus minus as part of it. Okay? Any questions so far? All good in the hood?
Yeah.
Ready to move on?
Yeah.
All right. Let's take a look at problem number 4. Talk to me, friends. What should I do to the first thing to both sides? Add 20. Feel all right about that? So those cancel. So I get 2x squared equals 20 plus 20, which is 40. Then what? Good. Very good. Divide by 2. Reduce it if it does. 40 over 2 is 20. Next step, root. Don't forget the. So there's going to be a plus minus with it. So square root of x squared is x equals plus minus root 20. Okay, so now yeah, so 20 falls here. 4 is going to work. So I'm going to get x equals plus or minus 4 times 5. The reason I'm not using 2 and 10 is I want the biggest perfect square. What's the square root of 4?
2.
So x equals plus or minus 2 root 5. Feeling okay? All right. Now, I'm going to introduce you to a brand spanking new number system. Well, it's not really new. It's new to you. It's not new to society or world. All right. First thing I want to do, divide each side by, or subtract 27 from each side. Do you feel comfortable with that? And then I'm going to divide both sides by 3. What is negative 27 over 3?
Negative.
Negative 9. Okay. Do you feel comfortable with the math we just did?
Please slow. Hold on.
You got it.
Thank you.
Okay. So x squared equals negative 9. X squared means I'm taking a number times itself, exactly itself, and get a negative 9. Well, 3 times 3 gives me positive 9, and negative 3 times negative 3 gives me positive 9. So there's not a number that we know of up to this very moment that I can multiply with exactly itself that would give me a negative 9. Now, before, people say, oh, it's prime. Nope. We're going to do this. Ready? Root. Don't forget the. Okay. Are you okay so far? Okay. Are you okay so far with that? All right, friends. When you see this, you are going to write the letter I, and the negative sign from underneath is gone. The letter I is not a variable. The letter I stands for an imaginary number, which is part of something called the complex number system. Okay, and I'll explain that in a minute. Hey, friends, once I have that, what is the square root of 9?
3.
So I get the answer is plus or minus 3i. And again, I does not represent a variable. I stands for something. Okay? Is that the last example?
Yeah.
Okay. So we're going to take a little tangent. Was it okay to move on, or does anyone still need that? Okay. Still going, Joey?
I have a question.
Yeah.
So is it okay to written it like plus minus I3, or if you can't?
Technically, yeah. You could have plus or minus I3, but it, sometimes it's preferred to have the 3 than the I. But if you had I3, I'm not going to dock you on that. All right. So now let's go back. When we were in early years of schooling, we had something that they called the counting numbers. And that was 1, 2, 3, etc. And your teacher might have had a banner across the top of the board that had like 1 apple, and then you had 2 trees, and then 3 dogs, etc. Okay? So why they were labeling it with something is we could identify certain objects and put a numerical value of how many of those objects we have. And then we got so advanced, we got into something called the whole numbers. And these are the names of the number systems. And the whole numbers, the only difference between that and the counting is you include 0. Okay?
There is 0 apples.
And then you came across something called the integers. And the integers were the negative numbers. Integers had negative numbers. And then you went to something called a rational number. So the rational numbers are any number, all the numbers up above. So all these number systems are in order. Counting is 1, 2, 3. Whole numbers are all the counting numbers, and then you have 1. Integers are all the counting numbers, all the whole numbers, and then the negatives. And then the rationals are all the above, any that can be a fraction. Okay? Yeah, rational. And when I say a fraction, this also includes decimals that repeat or end.
Okay, hold on. Would 0 be a rational number?
Yes. Okay? So, it goes in this order. Counting is the first. Whole numbers are all the counting numbers and 0. Integers are all the whole numbers, all the counting numbers, and the negative numbers. Rationals are all the integers, all the whole numbers, all the counting numbers, and anything that can be written as a fraction. and that also includes a decimal that repeats or ends. So if you had 3.2, 3.2 is a rational number because it ends. If I had 3.6666666 forever, that is a rational number because it's repeating. You can figure out the fraction it goes with. We then came across something that was called the irrational numbers. And the irrational numbers were numbers that don't repeat as decimals or have a pattern. Okay? So numbers that you might know that are irrational would be pi, 3.14159. It goes on forever. Or square root of 2, or square root of 3, or square root of 5. All of these are irrational numbers. Okay? Now, all irrational numbers include the counting, include the whole, include the integers, and include the rationals. And then in order to say, and this all comes, the name of all of these number systems all put together is called the real number system. Okay.
What's not a real number?
Oh, thank you for asking.
What's a fake number?
It's not fake. It's not real or called imaginary. Okay, so that was one counting system, all that situation. Okay, that's kind of all the formative years. Then you have something called the non-real.
Yeah, just fake.
These are often called complex numbers. And a portion of the complex numbers are called the imaginary numbers. And I kid you not, this is the name of them. Now, the imaginary numbers are what we're going to focus on, and that's where we have the square root of a negative. If you have a square root of a negative, so if I had square root of -7, that is equal to I root 7. Okay, the I goes in front of the radical. There's no longer a negative there. If I had the square root of -9, that becomes 3I. Okay, notice I don't have plus or minuses because I didn't have to root both sides to get to it. I'm just reducing it. Okay, the non-real number systems is a larger number system than the real number system, which included the rationals, irrationals, integers, wholes, and counting. So the non-real. Now, I kid you not, when these are the names, it sounds like they're just making up stuff. What number you have? It's imaginary. You mean it's fake? No, it's imaginary. They're using a word that has all these different adjectives that go with it, and you're like, okay, it's imaginary. So it's not real? Correct. Well, when can it be real? It can't. Why can't it be real? Well, I can see it because it must be real. No, it's not real. It's non-real. What do you mean it's not real? Well, it's imaginary. You mean you made it up? I mean, it's the verbiage of the language. I would say our literary scholars, our people that are writing scholars, go completely bonkers with the mathematicians that are like, I have an idea. You're going to have a square root of a negative number. We're going to call that imaginary. And people are like, ooh. So.
The literatures are like, no.
Yeah, they have a hard time. All right, so. Yeah.
So, like my imaginary.
Gotcha. I'll even move it up a little bit so you can. Is that better?
Yeah, Connor's like,
I'm here to help.
My imaginary friends who actually have it right now.
So you got hit in the head with a tennis ball.
Yeah, I was going so fast. She served it at my head. I served my ear. And my
So why didn't she hit it back?
Should have thrown down.
You used your hand.
I was offering you.
Out of my.
Sure, please go up to see you.
Okay, now I know I'm looking. Still with your arm. Okay, thank you. What did you really?
Thank you.
That enough?
Really? Drilling. Are you drilling? Oh, no, I used to draw things like that.
I've never done
We good? All right, so just so you know, friends, what do you think this answer is?
3I.
3I.
Let's go.
What is this answer?
Oh, you.
What's that answer?
2I.
What is this answer?
2i. Or 5i.
5i. Okay? So if I had something like this, x squared is equal to -9, if I took the square root of both sides, don't forget the plus minus, and then what's the answer?
Plus minus 3i.
Okay. That's it. That's it. That's all it is. Yeah.
So for the 9, why did we do 3? Because now this is like a perfect square.
Sure it is.
3 and 4.
3 times 3 is
Oh,
9.
I'm sorry.
That happens.
Wait, sir.
Waiting.
I have a question. What if
Hey, can't talk.
0 doesn't, no, 0 is literally, it's
I-
the only number without a positive or a negative. It's the only neutral number. So what do you do if you have a square 0? Wouldn't it just be 0?
If you had this,
Yeah.
root,
0i?
There can't, but there has to be 2 answers. There can't be 2 answers.
this is the only time it doesn't.
Wait, there's the only one that doesn't have 3 answers?
0.
Yeah, 0.
One answer only.
Oh.
What's this about 0?
I have 0.
0 can't have 2 answers.
Yeah.
Yeah, 0 is the only one that's...
Weird.
All right, yes, it is weird. All right.
I had 0 friends that did that.
I also think Mr. Sir is weird. He's weird in a good way.
Oh,
I could be weird in a bad way, too.
yeah, me too.
All right, so
A lot of
my friends. I think you can easily get done with page 159 and 160. Do all of them. I will assure you there might be a problem or two where you're like, wait a minute, I'm not quite sure how to do this. Well, try it. Do them all. Try them all.
1, 2, 3, 4.
Got it?
Yes.
Excuse me,